Okay, here's a simple problem I made up for Colin's Baked Goods. From the written description down there, you can see we have three constraints, one for mixing, one for baking, and one for taste testing. All right, given these three constraints, hopefully you can see this, this is what the graph would look like. I'll leave you to figure out x1 and x2 values. So look at the mixing, or first look at the feasible region, which I have shaded in red. It's between 5 and 5, and we can call that fourth point there maybe 3, 3. So that's the feasible region. So a binding constraint helps establish that feasible region. So that's our testing and our baking. If you look at the mixing, it's way out there, and it really doesn't affect the feasible region. So that's a redundant constraint. In other words, it doesn't limit us at all, so it's redundant. The amount of redundancy is measured in slack. All right, let me just draw it out for you really quick. Okay, what I've done here is just drawn in some the coordinates for you. You can see at 3, 3, I'm estimating that intersection of taste and bake to be about 3 of each, whereas mixing would be somewhere around 10 of each. I'm probably a little off in my drawing there, but you get the idea. So I would have 7 units of slack in both x2 and x1 for mixing. And again, taste and baking are my binding constraints. So you get it, redundant is extra, slack is the amount of extra, and binding is what limits it. The one thing you want to look at is, look at point D, 5 and 0. At 5 and 0, we do have extra capacity in baking. So in that case, there would be extra slack in baking, as opposed to on the x2 axis, 0, 5, we'd have 5 units of slack for tasting. You could always eat more, Sean. Anyway, hope that helps. So you notice from our original problem that we make $8 of profit from cupcakes and 10 for cookies. Well, it's the same as the extreme point method. We just take the different coordinates from the graph, we plug them into the profit equation, which is our $8 for cupcakes and $10 for cookies, and you can see our optimal solution is point C with $54 of profit. So that's how you calculate profit. You just substitute the coordinates back into the profit equation. All right, let's talk about an infeasible solution. So I've changed our problem so the mix has at least 450 hours, which makes it a greater than or equal to constraint rather than a less than. And what that does to our chart here, you notice now the solution has to be greater than mix, but still taste and bakes are less than. So there is no solution to this problem. It's infeasible. Given the current constraints, you cannot maximize profit. So simply, either you've got to ask for more resources so you can get a solution. You have to ask your boss or whomever for more resources, or you decide not to do it because you can't make a profit. So it's either one of those two is an acceptable answer.